with two of your other friends, have just been sent to Venus, Mars, and Saturn's moon Titan to conduct studies on hearing what it would sound like on those planets. You, on the frigid landscape of Mars, have just landed on the dusty, lifeless surface of the Jezero crater, the same place the Perseverance rover landed at. NASA has equipped you with a science-fictional suit that will replicate any sound you make and will yell it out into the dusty surface in front of you. Then, the echoes the terrain around you make will be able to make you hear the sound of Mars. Now, Mars is a little weird when it comes to the concept of sound. Because Mars has a thinner atmosphere than Earth, sounds will be more muffled as there's less air molecules to transmit sound waves. If we yelled out what Carl Sagan's son said on the Voyager Golden Record, it would sound something like this.
Hello from the children of planet Earth.
Another factor is of Mars's carbon dioxide composition. Carbon dioxide takes up roughly 96% of Mars's atmosphere, and due to carbon dioxide being a heavy gas, sound on Mars would make you sound like you have a deeper voice. Other factors include temperature, humidity, surface conditions, and Martian wind. Due to this, the voice as before would sound similar to this.
Hello from the children of planet Earth.
Next, one of your other friends just landed on Venus with a science-fictional suit and ship. On Venus, its atmosphere is mostly made up of 96% carbon dioxide and traces of other gases and the rest of the 4%. Because carbon dioxide takes up most of the atmosphere, this causes sound to, as previously, lower in pitch. Your voice would also be muffled due to the denser atmosphere absorbing higher frequencies more than lower frequencies. The terrain around you would also echo sound back to you, however in a very little amount. Using data from the Soviet Union's Venera mission during the 60s to 70s, we can estimate what sound would be like on Venus. Because of the data they sent back, we can infer based on the atmospheric composition, temperature, pressure, and surface conditions that Venus sounds distinctive compared to Earth. The following is of the same clip of Carl Sagan's son, however differed to replicate what he would sound like on Venus.
Hello from the children of planet Earth.
Lastly, one of your friends manages to land on Titan, the frigidly interesting moon of Saturn. Using data from the Voyager missions, we discovered that Titan is mainly comprised of methane and ethane. Along with this, after a 1995 study by the Hubble Space Telescope, methane water could have had the possibility to exist on Titan's surface. This hypothesis would turn out true in 2006 after the discovery of Kraken Mare and various other lakes on Titan's surface. On Titan, the speed of sound is 433 miles per hour. Compared to Earth, the speed of sound is only 767 miles per hour. However, Titan's atmosphere is denser than Earth's, roughly 21 psi. This would lower the pitch of your voice significantly. Additionally, weather on Titan is scarce, only having storms occur every few years due to the unbearably cold conditions, the warmest of which occurring during its summers with peak temperatures of negative 292 degrees Fahrenheit. Along with this is wind. Any celestial object with an atmosphere must have wind. In this case, Titan's winds reach a low of approximately 2 miles per hour and a high of about 4.5 miles per hour, resembling the gentle airflow you might feel from a light breeze. The airflow and weather do not contribute to the sound you make on Titan, however the density and air particles do. The following is a reconstruction using various factors previously mentioned, combined together to create the ambience of Titan's atmosphere.
Hello from the children of planet Earth.
If you were to go underwater on Titan, the sounds you make would be very high-pitched. This is because methane, which makes up Titan's liquid hydrocarbons, is denser than water. Sound travels faster in denser mediums like methane compared to water on Earth. This difference in density contributes to the perception of higher-pitched sounds underwater on Titan. The following is an underwater view of what you will sound like in Titan's methane lakes. Beware, the following contains high-pitched sounds. If your device cannot handle these sounds, please turn down the volume until the clip is over. The short, chipmunk-like audio clip is, according to various spacecraft flybys and one probe landing, the most accurate depiction of the underwater ambience heard on Titan. And the mission comes to an end. Your friends have safely returned to Earth. Wait a minute, they forgot their recordings. Well, at least we learned and listened to various ambiences of the celestial bodies we call our solar system. I couldn't have done it without you and your friends.